Good morning to all. Myself, Dr. James Monsoye. Today we are going to discuss some topic from the electrodynamics, some basic mathematics involved in the electromagnetic theory. So directly we are going to the portion. First we are going to discuss gradient of a scalar function. Gradient of a scalar function. Actually, we know that. Let's consider in electrodynamics, we have a scalar potential phi and vector potential A. Let phi is the scalar potential. If any question is asked to find out the gradient or del, actually the gradient is represented by del. That is the given the value I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Sometimes maybe it is written as x cap because the unit vector in direction of x, unit vector in the direction of y, and the unit vector in the direction of z. So the scalar gradient of the scalar function or the scalar potential of phi is represented by del of phi. So del is a vector quantity, phi is a scalar quantity. If it is, we can write it as that's equal to I into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z. Based upon this gradient, there are different equations or depend upon the dot product and cross product. I consider del of, if we have two function, del of f g, then we can apply the product rule. First into derivative of second one. That means f del of g plus g into del of f. Similarly, you want to study some equation to solve the equations or the question. So if the other properties of this scalar functions, del of, if the product of two functions, a dot b, del of a dot b is equal to a cross del cross b plus b cross del cross a plus a dot del into b plus b dot del into a. The another equation gradients del of del dot of a cross b. This cross product a cross b is equal to ab sin theta. A dot b is equal to ab cos theta. A cross b is equal to b dot del cross a minus a dot del cross b. Then one more equation that is very urgent. We want to very useful for us to solve. If there are two product or two cross product, del cross of a cross b, del cross of a cross b is equal to b dot del into a minus a dot del into b plus a into del dot b minus b into del dot a. One more equation is 1, 2, 3, 4, fifth equation. Del cross of a function into a. That's equal to f into del cross A minus A cross del F. There are different type of equations. These five equations that we can be used for solving different equation. In different cases, this equation is very needful to use in different cases for solving our equations or question. So we can directly, so going to the question, we can find out the gradient of some function. So let's consider the question is given as, let's consider our f of x is equal to, or f of x, y, z is equal to x square plus y cube plus z raised to 4. So we want to find out the answer. We want to find out the gradient. So in sometimes in part B, we can calculate the gradient in question analytic preparation or examination. So del of this one, I into dou by dou x of this f plus j into dou by dou y of this function plus k into dou by dou z of this function. So that is equal to dou x of this function that we want to differentiate with respect to x. Now, x want to differentiate we know that the function is in terms of x, then this two term becomes 0, then that is equal to 2x plus I into 2x plus j into dou by dou y cube, then n into y raised to n minus 1, that's equal to 3y square plus k into dou z or 4z cube. So this is our answer. That means we can find out the value of del. Then we x want to differentiate here. That x in the term in differentiate that is 2x out. Y cube into 3, y square out. Z raised to 4, 4 z cube out. That means d by dx of x raised to n. That is equal to n into x raised to n minus. Okay. Now, if you need, we want to solve one more equation. Let's consider f of x is equal to x square y cube z raised to 4. Then del of f is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z of this x square plus y cube plus z raised to. Then we can derive in terms of so this is the same question that we already proved. We can take another question. We can remove the, no, here it is in multiplication. Sorry, we can remove this part. So our question is become of x square y cube is raised to 4. Then first we will derive in terms of x, dou by dou x of x square, that's equal to 2x. Then it is multiplication. So we want to write the term of y cube as z raised to 4 because function with respect to the derivation of x, then this y and z are constant, plus I into plus j into dou by dou y of, that means x square into 3y square into z raised to 4 plus k into dou by dou z x square y cube z raised to 4. നമുക്ക് സംശയം വന്നത് മുമ്പേ ചെയ്ത ചോദ്യം എക്സ് സ്ക്വയർ പ്ലസ് വൈ ക്യൂബ് പ്ലസ് ഇസഡ് റേസ് ടു 4 ആയിരുന്നു. ഇവിടെ ചെയ്തത് എക്സ് സ്ക്വയർ പ്ലസ് വൈ ക്യൂബ് എക്സ് സ്ക്വയർ ഇൻറ്റു വൈ ക്യൂബ് ഇൻറ്റു ഇസഡ് റേസ് ടു 4. So the answer is different. We can simply find out the del or the gradient of a function. If there is any gradient, if we want to find out the gradient of a function, take the del of that function. Now Let's consider another question, different type of question is there. Let's consider one question. Let R be the separation vector from a fixed point. That means R vector is the separation from a fixed point. X prime, Y prime, Z prime to a point X, Y, Z. That means the question is given in such as that R is the distance between these 2 points. Let's consider this is P and this is the point Q. Then let R be the length, R be its length, so that del square R equal to 2R. We want to prove or we want to find out the value of del square R. The value is given, that is equal to 2R. Del square of R is equal to 2R. Let's consider R is the distance between these 2 points Q and P. Then R is equal to in vector form, vector R is equal to, if x1 and x1 y1 is z1, x2 y2 is z2, we already know that the distance between x2 minus x1 into I plus y2 minus, similarly we can write it as x minus x prime into I plus y minus y prime into j plus z minus z prime into k. So now this is vector R. Now the modulus of this vector or this R value of this R is equal to root of component of x square plus component of y square plus component of s square. That means x minus x prime whole square plus y minus y prime whole square plus z minus z prime whole square. So ചോദ്യത്തിൽ നമുക്ക് ഇങ്ങനെ രണ്ട് പോയിന്റ് തന്നിരുന്നു. അതിനകത്ത് നമ്മൾ R കണ്ടുപിടിച്ചു. x2 minus x1 plus y2 minus y1 plus z2 minus z1. So x minus x prime, y minus y prime, z minus z prime. Modulus, take the value of that vector R is equal to root of x2 minus x or x minus x prime whole square plus y minus y prime whole square plus z minus z prime whole square. Now we can, if we need, we want to take, if any questions, we want to find out the square of R square, we want to take the R square such that R square is equal to this whole square. That means 1 by 2. Root that we can write it as 1 by 2 into 2. That means 1. Then this root is cancelled. So R square is equal to x minus x prime, the whole square, plus y minus y prime, the whole square, plus z minus z prime. Now our question is that, now our question is find out del. Sorry, del of R square. Del of R square is equal to 2R. That we want to prove. We know that del is equal to I into dou by dou x plus j into dou. So del of R square is equal to, here we find out the value of R square. So I into dou by dou x plus j into dou by dou y plus k into dou by dou z into R square. That means x minus x prime whole square plus y minus y prime whole square plus z minus z prime whole square. So we can take the derivative of each one with respect to x. Then x prime with respect to x, this is a variable. It's equal to 2 into x minus x prime all raised to 2 minus 1, 1 plus 2 into with respect to y, y minus y prime plus 2 into z minus z prime. Now, x minus x prime plus you can take it as 2 is common. Then x minus x prime into I plus j into y minus y prime plus k into z minus z prime. This is our value of R. So the answer is 2R. So del of R square. just del of r square is equal to 2. അപ്പൊ നമ്മളിപ്പം del അല്ലെങ്കിൽ gradient of a function കാണാമെന്ന് പഠിച്ചു. It's very simple. I into dou by dou x plus j into dou by dou y plus k into dou by dou z. ഇതുപോലെ തന്നെ നമുക്ക് ആവശ്യമുള്ള മറ്റൊരു ടേമാണ് ലാപ്ലേഷ്യൻ ഫംഗ്ഷൻ കണ്ടുപിടിക്കുക, അല്ലെങ്കിൽ ടി, ക്യാപിറ്റൽ ടി. സംടൈം ഇറ്റ് ഈസ് റെപ്രസെന്റഡ് ബൈ ക്യാപിറ്റൽ ടി. So let's consider, that means that twice of gradient that create Laplacian function. Let's consider del of del dot of del t. Del dot means del square, that is equal to del square of t. This is actually called the Laplacian of function t. So if there is any direct equation, we can simply find out the second derivative of our del or I into that value. So some more properties for this Laplacian. So del into t is equal to del square t. Del cross of del t is equal to 0. Del of del dot v. Let's consider v is any function, then it represents the gradient of divergence. This is gradient. This is a dot b or del dot v, that is divergence. Gradient of divergence. So if there is a function is given, and if the question is like to find out the gradient of a divergence, then we want to find out del of del dot v. Gradient of divergence. Then some equation, more questions that we need. Del dot of del cross v, that's equal to 0. Then del cross of curl of a curl. Del cross of del cross. മുമ്പ് നമ്മൾ പറഞ്ഞ പോലെ ഇത് വളരെ ആവശ്യമായിട്ട് വരുന്ന ഈ ഇലക്ട്രോഡൈനാമിക്സ് സോൾവ്. Del cross of del cross v is equal to del of del dot v minus del square. So if you have any question, if we want to study these equations, we want to do the equations similar way. If you want to find out this one, you can take this derivative or this equation. So let's consider one question is given, that is to find out the Laplacian of a function. Let's consider the t is given. Calculate the Laplacian. Calculate the Laplacian of the function t is equal to x square plus 2xy plus 3z plus 4. Then we want to find out this Laplacian or del square of t. That means del square of t. That's equal to del of del t. So we can find out the first derivative. Del of t is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z into or of t x square plus 2xy plus 3z plus 4. That's equal to, first we want to take the derivative of x, that is equal to 2x. Then I into 2x, because you should write here I, because we are taking second derivative. Again we want to multiply it with I. Then I into I is equal to 1. That means here it is a vector form. That means I into 2x plus j into dou by dou y of this one, that is equal to 2x plus k into z, 3z, that is 3. That is a del of t. Now we want to again take del square of t. Then take the del of this equation, that's equal to I into dou by dou f to 2x is equal to 2 plus there is no term with respect to I, that means next term is equal to 0, and also next term with respect to z also become 0. So del square of t is equal to. So here our equation is I into dou by dou x of I into 2x. That is our first term. So I square, that is equal to 1. Then 1 into dou by dou x of 2x, that's equal to 2. So here we obtain the value as a scalar value, or it is only depend on its value. So the Laplacian of this t gives that value answer is equal to 2. Here I would like to give some example, some more example of the same question and its answer. It's simply you can do by yourself. We can take the second derivative with respect to the del. Take the first derivative and take the derivatives once again, then we get the answer. That means the question is, let consider the Laplacian of the function tb is equal to sin x into sin y into sin s. Then its answer is minus 3 into sin x into sin y into sin x. This is equal to. One more question. E raised to minus 5x into sin 4y into cos 3x. You can say it is easy. Then we obtain the answer is such that answer is equal to, its answer equal to 0. Then one more equation. Let's consider the function is given as v is equal to x square into x plus 3x z square into y. Here the I is represented by x cap, that is only difference. Plus minus 2x z into z cap. Take the second derivative of with respect to L, the answer is should be like this. The answer is equal to 2x minus 6. So for more experience, you can you can find out the del square of these functions. Then you get the answer is take the first derivative of del of this function, take one more time. You should obtain the answer. The first one is equal to minus 3 into sin x sin y sin is. This answer of the second question becomes 0. The answer is the third question is about 2x minus 6xy. Actually, this gradient, then Laplacian. Then one more thing that we want to discuss is the Kronecker delta function or delta function. So it is also be called the Dirac delta function. Dirac delta function, or it is represented by small delta. Let's consider this is a graph of x. This is a variable and a particular value x0. We obtain a value with respect to x minus x0. Then only at this point, when x equal to x0, that means del of x minus x0 is equal to 0 all other points. It means if x not equal to x0, the value should be 0 or 1, or we can write as if it is taken as infinity only at when x equal to x. These are the major three derivatives or gradient, then Laplacian and Dirac delta function, the basic mathematics that is involved in our electromagnetic theory. So some more properties of this one is the important properties is that del of minus x. If a function is even, then that's equal to del of x. Then if del of a into x, where a is a constant, then we want to take 1 by a into del of x. Then if you take the integration minus infinity to infinity, del of x dx equal to 1. These are the simple and major equation that we want to needed to solve some problems. More equation is there. So at least you want to by heart or you want to understand this equation, especially this equation. For a constant in any function, then we can take the ratio 1 by a into del of that function. So നമ്മളിപ്പം ഇവിടം വരെയും ഡിസ്കസ് ചെയ്തത് ബേസിക് മാത്തമാറ്റിക്സ് ഇലക്ട്രോമാഗ്നറ്റിക് തിയറിയിലേക്ക് നമുക്ക് പ്രോബ്ലം സോൾവ് ചെയ്യാൻ വേണ്ടതാണ്. നമ്മൾ ഗ്രേഡിയന്റ് ഓഫ് എ സ്കെയിലാർ ഫംഗ്ഷൻ അത് വെച്ച് നമുക്ക് പ്രോബ്ലം ചെയ്യാം. ദെൻ അതിന്റെ സെക്കൻഡ് ഡെറിവേറ്റീവിന്റെ ടേമിൽ വരുന്നത് ലാപ്ലേഷ്യൻ അതിന്റെ പ്രോപ്പർട്ടികൾ അതിന്റെ പ്രോബ്ലം. ദെൻ നമ്മൾ ഇപ്പോൾ ഡിറാക് ഡെൽറ്റ ഫംഗ്ഷൻ അതിന്റെ ബേസിക് പ്രോപ്പർട്ടികളും പഠിച്ചു. So now we are going to the problem solving section of electric field and potential in a vacuum.